right, go and take out your speed drill and review exercise booklet. Open to the page 19. It's speed drill 19. Practicing with division. You've got some division of fractions, got some division with decimals, got some other division as well. You're going to have 5 minutes to complete this speed drill exercise. So if you would, get ready to begin, and once you're ready, pause the video for 5 minutes while you complete, and then we'll go over the answers together. All right, go and exchange exercise booklets so that you do not have your own. If you would, go and sign your name at the bottom as the grader. And these are going to be 15 points each. 15 points each. We'll go across the top row first of all, and dividing by a single digit 5 should have given you an answer of 86. 86. For the next one, dividing by 3 digits, but really kind of more like 2, should have gotten 44. 44. For the next one, should have gotten 25. 25. For the next one, we need to move the decimal over 2 places, and when we divide, we get 0.239. 0.239. That's probably the last one I would have worked if I were working these. And then the last two, dividing with fractions, these might have been what I started with, is dividing with fractions really isn't too bad as long as you multiply by the reciprocal. For the first one, would have gotten 5 and 25 48ths. 5 and 25 48ths. And the next one would have gotten 3 and 29 37ths. 3 and 29 37ths. And there is some partial credit I can give, but for now, if it's not what I said, go and take off all 15 points. Obviously, minus 0 would be a 100. Minus 1 would be an 85. Minus 2 would be a 70. Minus 3 would be a 55. Hopefully they didn't miss 4. That would be a 40. Put the score, if you would, next to where it says Speed Drill 19 on the Speed Drill score page. And return to the owner. All right, once you've got yours back, check and see how you did. Were there any hundreds on this speed drill? Lana got 100, excellent. Any other hundreds? Good, all right. Go and pass those in. If you would, take out your homework. Page 386 was where you had your homework over the weekend. Page 386, the homework section, just doing numbers 1 through 10. So a little bit of a shorter homework assignment this past weekend. Page 386, numbers 1 through 10, we've begun looking at the probability that this or this occurs. You understand that adding in the word or gives you better chances, right? For instance, what are the odds I get a hunting rifle or a BB gun for Christmas? Well, if you were just hoping for the hunting rifle, the chances might be pretty slim depending on how rich your parents are. But if BB gun is acceptable to you as well, maybe now your chances went up considerably, right? Or well, she's pretty and she's pretty. So what are the odds that either she or she says yes? All right, well, you increased your odds by widening the net, so to speak. But we're going to look starting tomorrow at the word and. Well, you realize that cuts your chances down. Right now, it's almost like being greedy. What are the chances I get a rifle and a BB gun for Christmas? Though why you want the BB gun once you have the rifle, I'm not sure, unless you just have a cat problem in your neighborhood. Then the BB gun may really come in handy. Anyway, this is not politically correct to endorse that sort of thing. But anyway, or what are the odds that she says yes to go out with me, and we stay together for the next like 5 or 6 years, and we get engaged, and we get married? Okay, now your chances keep getting smaller and smaller the longer you go, right? And cuts down on your chances. Try to get too many things to happen just the way you want them, or widens the net, so to speak, and gives you more probabilities. And we said whenever you've got the word or, what do you do with the individual probabilities, class? You simply add them together, right, which increases your chances. So number 1, you're supposed to express in probability notation the probability of a truck or a plane being chosen for something. How would we write that, Scott? Right, P truck plus P plane. What about the probability of a sweater or a jacket? Though on a day like this, it's definitely heavy coat. But anyway, number 2, Lana?
P sweater plus P jacket.
P sweater plus P jacket. Good to go on that. Pretty easy. Good. All right, number 3. A number cube with the numbers 1 through 6 on its sides is rolled. What is the probability of rolling a 1 or a 6? Joshua?
1 to 3.
Good. It comes to 1 to 3. 1 to 6 on the 1, 1 to 6 on the 6. Add together to get 2 to 6 or reduce to 1 to 3. What about a 2 or an odd number, Scott?
2 to 3.
2 to 3. There's a 1 to 6 chance on the 2. There's a 3 to 6 chance on the odd number that gives you 4 to 6 or 2 to 3. Notice, by the way, 2 and odd do not overlap at all, correct? They are mutually exclusive. And in fact, everything we looked at here was mutually exclusive. Today we're going to begin looking at, well, what if they're not mutually exclusive? We'll look at that here in just a little bit. What about a number less than 3 or greater than 4? Well, how many numbers are less than 3, class?
2.
2. 1 and 2. How many on the die are greater than 4? 2, 5, and 6. So 2 to 6, 2 to 6 gives us, Lana, 2 to 3 when you reduce. Number 4. The spinner below is spun 1 time. What is the probability of spinning a 1 or a 4, Joshua?
2 to 5.
2 to 5. Assuming equal areas, by the way, on each of those sections, and they do appear to be. Yeah, 2 to 5 probability of spinning a 1 or a 4. What's the probability of spinning a 5 or a green area, Scott?
4 to 5.
4 to 5. There's 1 to 5 on the 5. There's 3 to 5 on the green areas, so that would come to 4 to 5. And then what about an even number or a purple area, Lana?
4 to 5.
Good, there's 2 even numbers, there are 2 purple areas. Again, they're mutually exclusive. There were no even purples. So we don't have to, it's just 2 to 5 plus 2 to 5 gives 4 to 5 probability. How many got 3 and 4 both correct, all 3 parts? Excellent. Number 5. Paperclip container has 12 red, 8 blue, 5 green, and 3 yellow paper clips. By the way, how many hate colored paper clips? All paper clips should be silvery. Okay, you're not teachers. I hate colored paper clips. Anyway, colored paper clips, here we go. What is the probability of randomly drawing yellow or blue, Joshua?
11 to 28.
Good, there are 28 total paper clips. When you add the yellow and the blue, it comes to 11 to 28. What about red or green, Scott? 17 to 28. What about yellow, green, or red, Lana?
5 to 7.
5 to 7. 20 to 28 reduces to 5 to 7. What's another way they could have worded letter C? Instead of saying yellow, green, or red, they could have just said the probability of not blue, right? And then they could have found the complement of blue. Blue being 8 to 28, or 2 to 7. So the probability would be the complement 5 to 7. Questions at number 5. All right, number 6. Jar of mints has the following flavors: 6 spearmint, 8 cinnamon, 12 peppermint, and 3 chocolate. I guess they mean like the Andes mints, like you get at Olive Garden. Anyway, what's the probability of randomly drawing a spearmint or a peppermint, Joshua?
9 to 14. Wait.
I think you may have mistallied them. Did you have 28 total?
No, I had 29.
Okay, that's correct. 29 total. All right. So we said how many spearmint?
Wait, is it 18 to 29?
It is. There's six
I think
spearmint and there's
I
12
had
peppermint.
28 at first because I miscounted them at first, but then I saw it, but I never changed the answer.
Gotcha. I was wondering how 9 to 14. I was like, you must have had 28 total initially. Okay, so 18 to 29 is correct. How about a chocolate mint or a cinnamon mint? Scott? 11 to 29 when you add the chocolate probability plus the cinnamon probability. And the probability of not cinnamon or the complement of cinnamon would be what, Lana?
21 to 29.
21 to 29 questions on that. All right, now we come to probabilities that don't need to be written as ratios because they've written them as percents. And the probabilities of grocery shopping. What percent of customers came on these different days? Notice 15% of the customers came to the grocery store on Sunday, 12% Monday, 12% Tuesday, 13% Wednesday, 13% Thursday, 16% Friday, and 19% Saturday. And if you've ever been shopping on a Saturday at Walmart, it's horrible. I've discovered Sundays are just as bad when I try to go after church. It's awful. Except during the Super Bowl, I did go to Walmart. It was like a ghost town. It was great. I got right in and out, no problem. But that's because I was listening to the Super Bowl on my phone while I was walking around Walmart, and I didn't care. All right, anyway. Number 7. What is the probability that a randomly selected individual shopped on Friday? Joshua?
16%.
Yeah, it's as easy as looking at the chart. 16% shopped on Friday, so there's your answer. What about shopped on a weekday, Scott?
66.
Now, there's 2 ways you could have found that, Scott. One way is to add up.
All of the weekdays.
Right, Monday, Tuesday, Wednesday, Thursday, Friday, get 66%. Another way you could have done it.
Subtract the weekends.
Right, subtract Saturday and Sunday, which adds up to 34% from 100% to get your 66%. Either of those would have worked. What about shopped on Monday or Saturday, Lana?
31%.
31%. Again, that or means you simply add them and did not shop on Tuesday. Please tell me you didn't add all the other days of the week. What do you get here, Joshua?
88%.
Right, and what did you do to get that?
You just subtract 100 minus 12.
100% minus 12%. Excellent. Questions on the homework from last time? All right. Well, let's talk now, if you would, about probability of a compound event when events are not mutually exclusive. For instance, we look over at the bulletin board over there, and you notice the third one, the second one on the second row says, what are the odds of choosing a candy off the top row or choosing a caramel? Well, there are 12 candies on the top row if you look at the chart. So 12 of the 74 candies in the box are top row candies. There are 8 caramels in the box. So 12 to 74 plus, because it says or, 8 to 74. But on the top row are 4 caramels. So those two are not mutually exclusive. There are some, 4 to be exact, that are both top row and caramel. Does that make sense? The overlap, that which satisfies both conditions, notice has been subtracted. It sort of overinflates to say, well, there's 12 top row and there's 8 caramel. Well, yeah, but 4 are both of those. Does that make sense? So the overlap or the both get subtracted away. So when events are not mutually exclusive, one with the other, we would take the probability of A plus the probability of B, but we have to subtract the probability of both, or as I like to call it, the overlap, that which satisfies both criteria. Does that make sense? So we're still kind of adding, but we have to tack on a little subtraction if things have some overlap to them. For instance, let me throw some numbers at you here. I'm a football nut, okay? So we'll go here. There are 32 NFL teams, 32 starting running backs in the NFL, right? Of the 32 starting running backs, jot this number down, 8 of them had over 1,000 yards. 8 running backs had over 1,000 yards rushing this season. One of them had over 2,000 yards, Derrick Henry of the Titans. But 8 of them had over 1,000 yards rushing. That's 8 out of 32. Well, I was also curious how many starting running backs rushed for 10 or more touchdowns. Well, there were 8 running backs who had 10 or more touchdowns. So if you just looked at this, you'd be like, oh, so 16 out of 32, or half the running backs, had 1,000 yards or 10 plus touchdowns. But realize some of the guys who are getting the 1,000 plus yards are, by virtue of all the yards they're getting, going to get some of those touchdowns, right? To be exact, there were 5 running backs who had over 1,000 yards and 10 plus touchdowns, including the guy who rushed for my Colts, Jonathan Taylor. He had over 1,000 yards and he had 10 plus touchdowns. So there were 4 other guys who were in the same boat, including Derrick Henry. Okay, so what I'm going to have to do to figure out what's the probability that an NFL team selected at random had a running back who either had 1,000 yards or 10 touchdowns. Or always means, class, we add. But if there is something, or in this case someone, who fits both criteria, we have to do what? Subtract the overlap. So, class, what is the probability that any NFL team picked at random would have had a running back who rushed for over 1,000 yards or had 10 or more rushing touchdowns? 11 to 32. There were 11 NFL teams whose running back either had 1,000 yards or 10 touchdowns. Does that make sense? Subtract the overlap away. Look at the example problem on page 387. At the top of the page, there's this guy who wants to land safely. George is playing this board game, and he rolls the die, and he knows that if he rolls something less than 4, he'll be safe. Or if he'll roll an even number, somehow he's safe. I don't know, this is a weird board game. He needs something less than 4 or an even number. Well, how many numbers are less than 4, class? 3. 1, 2, and 3 are all less than 4. How many numbers are even? 3, 2, 4, and 6. However, there is a number that is both less than 4 and even. And which number is the overlap here, class? The 2. That's one number out of 6 that has overlap. Do we see that? So 3 to 6 plus 3 to 6 minus 1 to 6 gives us a 5 to 6 chance. Pretty much, don't roll a 5, right? Is what it ends up being in this particular case. Do we see how we add the probabilities but subtract the overlap? Look at the example there on the bottom of page 387 now in the yellow shaded box. We have a spinner. Notice 1, 2, and 6 are green, 3, 4, and 5 are blue. It says, what is the probability of spinning a green area or an area with an even number? The probability of green or even. Notice they are not mutually exclusive because there are a couple of even greens, aren't there? So we want green or even. Well, what's the probability of green, class? 3 to 6. What's the probability of even? 3 to 6. How many are both green and even?
2.
2 of them, the 2 and the 6. So notice the overlap, the probability of both, has to be subtracted. 3 to 6 plus 3 to 6 minus 2 to 6, notice, gives 4 to 6, which reduces down to 2 to 3. Does that make sense? All right, look at letter B. What's the probability of spinning blue or number less than 5? Well, how many blues are there?
3.
3 to 6. What about less than 5?
4.
4 to 6, right? 1, 2, 3, and 4. So 4 to 6. But how many are blue and less than 5?
2.
2 of them, the 3 and the 4, are blue and they are less than 5. So since they satisfy both criteria, the 2 to 6 is subtracted away. Notice we have 3 to 6 blue, 4 to 6 less than 5, 2 to 6 overlap, subtracted, gives 5 to 6. Do we see how to work with not mutually exclusive events? Subtract away the overlap. All right, so turn the page. Let's think through numbers 1 through 4. Let's figure out, will these be mutually exclusive or not? Look at number 1. If you were to reach into a bag and draw the letter E or draw a vowel, are those mutually exclusive?
No.
No, E is a vowel, right? Now, there are 5 vowels in the bag, right? And E is a vowel, so there's overlap. Basically, you'd have to subtract the E back away again, which is kind of inefficient, but whatever. Does that make sense? So how they're not mutually exclusive. All right, number 2. Rolling a number less than 3 or a number less than 4.
Yeah.
Are they mutually exclusive or not?
Yeah.
No.
No, because numbers that are less than 3 are also less than 4, aren't they? Right? 1 and 2 are less than 3. Well, they're also less than 4. So they're not mutually exclusive, right? There's overlap there. Look at number 3. Selecting a chicken picture or a dog picture from a pile of animal pictures.
No.
Those are mutually exclusive.
yeah.
That which is a picture of a chicken is not a picture of a dog. Those are clearly mutually exclusive, right? Now, if it said chicken picture or bird picture, those are not mutually exclusive, right? Because birds are, and chickens are birds, right? There's overlap there. But chicken and dog are totally separate. Those would be mutually exclusive. What about number 4? Selecting a snake picture or a reptile picture.
No.
No, because snakes are reptiles, so those would not be mutually exclusive. Does that make sense?
Mm.
All right, so then, jump across the page now. Do numbers 1 and 2 at the top of page 389. Go across the page to page 389. I want you to do numbers 1 and 2. Determine yes, mutually exclusive, or no, not mutually exclusive. Take just 10 seconds or so to think through those. All right, Joshua, what do you think on number 1? Selecting a boy or a student from a group of people.
No.
Unless it's an all-girls school, not mutually exclusive, right? And there aren't a whole lot of all-girls schools anymore, so not mutually exclusive. All right, number 2, selecting a 4 or a prime number. Lana?
Yes.
Yes, because 4 is not prime. They do not overlap each other. Make sense? Look on numbers 5 through 8. The probability of a vowel or an A. Now here's my thought, class. An A is a vowel, right? So if I add, because of the or, the probability of the A, since it is the overlap, I'd end up subtracting it anyway, right? So really, I could just say probability of vowel. Do you see that would be a whole lot easier? All right, look at the next one, probability of water or liquid. Now technically what they want you to say is probability of water plus probability of liquid minus probability of both, but let's face it, Water is a liquid. Could we just say probability of liquid? Right? Because if the overlap is there, right? Like, if for instance, if every, just erase my example, but if every 1,000-yard rusher had 10 plus touchdowns, there'd be no point in having both, right? Just say the one that includes all of them, right? Or for instance, if all the top row were a caramel, or if all the caramels were on the top row, there'd be no point in mentioning them as separate groups. But because not all the caramels were top row, only some of them, now it makes a legitimate problem. They did a horrible job coming up with these. Right, like probability of femur or probability of bone. Wouldn't we just say probability of bone because femur is a bone? Or for instance, the probability of a pyramid or a tetrahedron? Why not just say probability of pyramid? Because a tetrahedron is a pyramid. Does that make sense? Yeah. Anyway, so I'm not a huge fan of their examples there. Now, if they said probability of even or prime, there is a tiny bit of overlap there, right? Because the only number that is both even and prime would be, but there are a whole lot of even numbers that aren't prime. There's a whole lot of prime numbers that aren't even, right? So that would be more legit. Their example is really not well thought out, but there's to help you get the idea of picturing the overlap. Does that make sense? Let's take a look now at number 9. Go ahead and read number 9 for us if you would, Lana.
A bag of marbles contains the following marbles: 4 large red, 3 large blue, 5 small red, and 8 small blue. 1 marble will be drawn from the bag. What is the probability of randomly drawn?
All right, let's go to letter A. A marble that is large or blue. Let's start with the probability of large. How many large marbles are there, class?
7.
7. How many total marbles are in the bag? Yes, 20 total. Sorry, I hadn't actually added them up yet. 20 total, 7 of them are large. Plus, then we want the probability of blue. How many marbles are blue? 3 blue marbles?
3 large.
Oh, there's 11 total, right? 3 large blue, 8 small blue, so 11 blue. But we have to subtract away the probability of both. And they actually did a great job on this one because not all the blue are large, not all the large are blue. How many are large and blue? Only 3 of them. So we're only going to subtract away 3 of those. What's the probability then of drawing either a large marble or a blue marble? Class?
3, 4.
Good. 15 to 20, which is 3 to 4. Does that make sense? We have 7 to 20 large plus 11 to 20 blue minus 3 to 20 both, large and blue, gives us 15 to 20, which reduces to 3 to 4. Does that make sense? Let me have you help me with the next one. A marble that is small or blue. So Lana, help me with this one. We already know, of course, that 11 out of 20 are blue. How many marbles are small marbles? 13 out of 20 marbles are small. We already said 11 of the marbles are blue out of 20. How many marbles are both small and blue?
8.
8. So do you see we're going to subtract away the overlap. Now, Lana, that means 13 to 20 small plus 11 to 20 blue so far is what?
24.
24 out of 20, which doesn't make any sense, but that's okay because we're going to subtract 8 out of 20 from the 24 out of 20 to get
16 to 20.
Good. There's a 16 to 20 chance of getting either a small marble or a blue marble. And of course, we could reduce that down any one to get
4 to 5.
4 to 5. There's a 4 to 5 chance, 80% chance, right, of getting either a small or blue marble.
Where
That's
did
just,
you get 24?
well, okay, you're adding small plus blue, that's 24 to 20 so far, then minus the 8 to 20. I didn't subtract it. We're kind of going in order, just a gradual progression there. All right, your seeds, do letter C, small or red. Small or red. probability of small, which we already did the last time, probability of red, which we hadn't done yet, minus the probability of both small and red, and it gives us, Scott,
19.
that's not what I got.
Oh, I added wrong.
Ah, okay, so what should we have got? Somebody else?
17 to 20.
17 to 20. 17 to 20, small or red. Starting to make sense? All right, last one, large or red. Large or red. Did we get 3 to 5 probability? Starting to make sense how to work with the subtracting that overlap, that both from everything. All right, number 10, a spinner below is spun once. What's the probability of spinning purple or odd? Give it at your seats. Purple or odd? Once you're done, check your answer. And what is that, a 62.5% chance, right? 0.625, so 62.5% chance of purple or odd. Is that what you got? All right, go to part B, green or something bigger than 3. Green or bigger than 3. I'm getting some confused looks, and that's not what my book has. Green or bigger than 3? Well, there's 3 greens, right? It says 3 to 8. Greater than 3 would be 5 numbers, right? 4, 5, 6, 7, 8 are all bigger. How many are both green and bigger than 3? 2. Oh, I can't subtract. 3 plus 5.
Yeah.
All of these were right, I just can't do basic math. 3 plus 5 is 8, minus 2 is 6. So let's try a 3 to 4 probability. I was just seeing if you were paying attention. Good job, class. Did y'all have 3 to 4 like you were supposed to? That makes me proud. Wish I could be. All right. All right, letter C. White or even? White or even? And you get 5 to 8. All right, feel like you got this?
I did not get.
You did not get 5 to 8. 7 to 8. All right, did you get there's only 2 white spots?
Oh, I added 1 instead of subtracting.
Okay, all right. Let's go on to number 11 then. The name of each month of the year was written on a separate piece of paper placed in a hat. One paper is randomly drawn. What's the probability of drawing a month that ends in R or has 30 days? Ends in R or has 30 days. check myself here. Yes? Alright, so you should have September, October, November, December are the only 4 that end in R. 30 days have September, April, June, and November. All the rest have 31, say February, which has 28 till leap year, give it 29. So that's 4 for 30 days. Or January, February, that's not 30. January, February, March, April, May, June, July, August, September, October, November, December. Okay, but anyways, there's 4 out of 12, however you want to do it. And then 30 days have September, April, June, and November. That's 2 of them that have both 30 days and an R. Subtract to get 6 to 12 or 1 to 2. Could you go on that one? All right, makes you think, right? How about a month that starts with J or ends with Y? Starts with J or ends with Y. Starts with J or ends in Y. Yes, I did. Okay. I've got 3 J months, 4 months ending in Y, and 2 that are both July and January. Both start with J and end in Y, so there's your overlap. So 5 to 12. All right, how about the last one? Starts with J or doesn't have 30 days. Well, how many did we say had 30 days? Well, let's keep the J there, right? Because we already said J was 3 to 12, right? Why are we going to redo work? And we said, how many have 30, class?
Well,
How many have 30 days?
4.
4, right? So does not have 30 would be the complement of 30, right? Which would be how many? 8 do not have 30 days. Now, how many start with J and don't have 30? July has 31, January has 31, and June has 30, so 2 of them. Yep, good. You were saying it, Josh, but I just had to make sure it was right because I was trying to think it through. So, what's the probability of picking a J month or a month that doesn't have 30 days? 9 to 12 or 3 to 4. Good. Questions on that? And number 12, I like this one, donuts or toruses, edible toruses. All right, anyway, Sunday school teacher randomly distributed a dozen donuts for a class of 1 each over 12 students, 5 powdered, 7 glazed. 5 were cream filled. 2 of the powdered were cream filled. 3 of the glazed were cream filled. All right, you got that? It's not 5 cream filled and 2 powdered and 3 glazed. 5 of the donuts were cream filled. 2 of the powdered were cream filled. 3 of the glazed were cream filled. Make sense? 5 total powdered, but only 2 of them have filling. 7 total glazed, only 3 of those have filling. Do we understand the situation? Okay. So you look at the box, 12 donuts in there, right? 5 have powder on the outside. 2 of those have filling. 3 of them ain't got it. 7 are glazed on the outside. 3 of those have filling. 4 of them don't have anything in the middle. All right? So, knowing that, what's the probability of glazed or cream filled? Glazed or cream filled? Good to go. Move on to letter B. Behind the back move. Get your feet down. Laughing at me. All right, Joshua, move on. Did you get it? 3 to 4? All right, 7 total glazed, right? There were 5 total cream filled, but 3 of the glazed were filled with cream. So that has to be subtracted away. And that's where you get 9 to 12. Moving on to letter B, powdered or cream. Powdered or cream? Stay with me for just a moment longer, study how you're dismissed. Powdered or cream? Powdered. Do we get letter B?
Oh, no.
I have 5 powdered, right? And there are 5 total cream filled, but 2 powdered are cream filled.
Correct.
10 minus 6
Ah. Let's try 8 to 12, which reduces to 3, or 2 to 3.
8. 2, yes.
How about that one? You like that one better? Smart. All right, that's twice in 1 hour. I should probably stop, but we need to go ahead and finish going over these for sake of video. Glazed or not cream? Well, obviously, if cream is 5 to 12, complement of cream would be 7. Glazed 7. How many glazed don't have cream? It says 3 glazed do have cream, so how many glazed don't have cream? 4. So that means there are 4 that are both glazed and are creamless. All right? And what do we get here? See, I was just ahead of my time. That's what it was. My mind was already into the next problem, already working it out before it even read it.
Where'd you get the 4 to 12 again?
Well, remember it said that it says right there that 3 of the glazed are cream filled, right? There were 5 cream filled donuts. 3 of the glazed happen to have cream. Well, if there's 7 glazed and 3 do have cream, that means 4 do not have cream and are glazed. So that's why I subtracted 4 to 12. Last one, powdered or not cream filled. Powdered or not cream filled. Powdered or not cream. So 5 powdered, 2 are cream, so 3 are not. Feels like the donut problems are the hardest.
Yeah.
It should be the most fun, the most edible. If I brought in real donuts, you could see them. That would have helped, right? Yeah, if I were a cool teacher, or if Golden Donut were open right now. See, I'm playing Golden
Where'd you
Donut.
get 3 to 12?
Right here. Well, it says that 2 powdered are cream filled, right? There are 2 powdered cream filled donuts. Well, if there's 2 that are cream filled and powdered, that means 3 of the 5 don't have cream.
Wow.
Again, it's the not that's kind of making that one more challenging. Tell you what, before we wrap up, just to make sure we're good to go ahead and work numbers 5 and 6 on page 389. 5 and 6 on page 389. Go ahead and pause the video while you work. All right, let's go and take a look at the answers here on page 389. Number 5, a marble that is large or blue should have gotten 7 to 10. For letter B, marble that is small or blue should have gotten 9 to 10. For letter C, marble that is small or red should have gotten 4 to 5. And letter D, a marble that is large or red should have gotten 3 to 5 for your answer. Number 6, for letter A, a red area or an even number should have gotten 7 to 10. For letter B, blue or number greater than 5 should have gotten 7 to 10. And letter C, white or odd should have gotten 3 to 5. All right, trust you did well. Your homework is going to be to do the handout that is in the description. There's a link in the description to a handout that you'll be completing for homework this evening, Lesson 118 homework handout, and have a wonderful rest of your day.